Good morning, all. And I hope now you are feeling much more comfortable with programming. In the yesterday's class, we have discussed the basic important feature of the programming, namely modularity, then readability, indentation, and of course, correctness is we have already always targeted. So I'm sure now you know these features, and let's start using these features towards programming at every level. As I already said, that for a few initial 1 or 2, 3 lectures, we can afford not to use modularity if you are not comfortable. So I will be sharing both aspects with you. And let me just do the focus to be more precise. Yeah. So I hope now the focus is better. Yeah. So for the initial 3 lectures or 4 lectures, the modularity will not be stressed upon, but later we will come upon that. So let's start talking of some good programming using data structures. And to start with, the first aspect which we are going to talk is polynomials to be stored and polynomial as a data structure which we are going to talk about. So when I say polynomial, primarily in the book you will study, there is a concept given as ADT, abstract data type. So all kind of data structures which we are going to study in the subjects, they represent various data types or data structures which are represented in an abstract manner. So abstraction is applied, and ADT we are not going to formally define. Of course, I will suggest you to read in the book also for more detail. But simply informally saying, I will say that whenever we are talking of ADT, we mean that we will be interested to know the external behavior of this particular data structure, knowing their storage related external representation and their operation related calls, etc., or operation related external visibility. Internal logic will be written inside the functions, etc., and that is not discussed when we talk of ADT. So polynomial is one of the simplest and useful data structures. So when we say any data structure, we are primarily interested to know its storage. So I want to know its storage, or I will say how to store polynomial inside the computer's memory. So representation of the polynomial at the computer level and operations to be applied on the polynomial. To start with, we are willing to do addition of 2 polynomials. So our focus of discussion for polynomial is its storage and addition of 2 polynomials using that storage. Of course, all of you are well aware. Let's say I have a polynomial, something like this. Maybe I have a polynomial like this. So it's a 1 variable polynomial, and this is a polynomial with a degree 5. So I know that for each polynomial, the highest exponent or the term with the highest exponent becomes the degree of that polynomial. So it's a polynomial of degree 5. So I want to store this polynomial. Now you have to think of what should be the storage for this polynomial. So what can be the possibilities to store this polynomial? If we are able to think of a suitable storage for this polynomial, the applications like addition or operations will become quite easy and straightforward over that particular storage. How should I store this polynomial? Primarily, if you see, what I am willing to know is now, once I know that I have a polynomial of degree 5, effectively I need the coefficients to be stored. So maybe you need the coefficients storage, etc. Maybe I say coefficient is 1, then I have coefficient 4, then I have coefficient -3, then I have coefficient 5. So these coefficients I should store. Maybe I can store them in some storage, some array, some structure, etc. But if I look carefully, even if I store only the coefficients, then I am not able to know whether -3 is coefficient of x power 3 or x power square. Like in between, x cube term was missing. Hence, there was no polynomials coefficient for x3 stored. And if I don't use that information in storage, I'll not be able to really manipulate or understand or comprehend this coefficients only. So in that case, either I can store the exponent as well as coefficient both. That is called as a exponent coefficient based representation. So that can be one alternate. But for the time being, today we are going to talk of a degree based representation. So degree based representation effectively means that I am going to store my degree and coefficients. Now, coefficients storage effectively will mean 0 to be stored for non-existing exponents. For non-existing terms or non-existing exponent terms, we will be storing a 0 for that. So that will mean effectively I will treat my polynomial to be something like 0 into x cube minus 3x square plus 0 into x plus 5. 5 is effectively x raised to 0. So effectively, this becomes my equivalent representation. Out of this, I will be willing to store 1, 4, 0, minus 3, 0, and 5. So these become my all coefficients. And I can easily say that if degree is 5, then I have these coefficients, and automatically meaning that this is a coefficient of x raised to 5. Next is obviously x raised to 4. Next is x raised to 3. Then x raised to 2. Then x raised to 1. And then x raised to 0. So I can definitely use this concept to refer to my all corresponding polynomial storage. Now, knowing that, I can easily see to storing coefficients, an array can be a good choice to store all this. So my storage can be array for storing the coefficients. If I remember this, now I will go to make a suitable storage for this. So I will say for each polynomial, I will be storing a degree and an array. So let's say array name I give. So for first polynomial, I say let it be called as a degree 1 and let it be called as a polynomial 1. Now, 0 onwards, so I will maybe, let's say I will declare an array of 50 elements, maximum, assuming that maximum 50 coefficients can exist. In that case, I am supposed to store all coefficients only into this. And I will be able to interpret it as a correct polynomial knowing degree. For example, degree is 5. So what value should be stored here? So there are two choices. One choice could be that I store here coefficient of x5, or I store here, other alternate you could think is coefficient of x raised to 0. So that the advantage of this will be that in the increasing indexes, this can be useful. I will say, preferably, we will be targeting to go to use the polynomial to be stored with the x raised to 5 exponents coefficient being stored here. That means probably this can be a suitable choice. Of course, other alternate can be used, but I will say this is probably a better choice. Why? I'll explain now. So I say we have to always keep in mind that a user's conventional working should not be disturbed at all. So user's conventional working is from the user, we always read, or we always, as a mathematics, we write or read my polynomials always from in the decreasing order of exponents. My always input given or way of writing of polynomial is this, not like this. 5 minus 3x square plus 4x4 plus x5. We don't write mathematically such. So first rule is always keep in mind that users' convenience has to be adjusted in the program's logic, and you should not unnecessarily ask the user to input or write the polynomial in the reverse order. So this can be adjusted in your program's logic. So hence, for that matter, we will say that user will input the polynomial in this particular order, which is x raised to 5 plus 4x raised to 4 minus 3x square and so and so. So read this and store it in this order only. Now, in storage, if you want to manipulate and store it in reverse order, can be okay, but you should ensure that the reading should be like this. So if I read like this, maybe I will say simplest choice could be to store in the order of coefficients 1, 4, minus 3, or before that I'll say 0 to be read now, and then minus 3, then 0, then 5. Of course, in this case, we are asking user to input 0 also wherever the term was missing. But that is something we can probably tolerate, or we can even manipulate while taking the input and adjust itself. But conventional order is being followed. So now I say this is my polynomial 1. Let's say I have second polynomial. So I will have a second polynomial also, and I should be able to read that, and similarly read that degree 2, read polynomial 2, and now aim is add 2 polynomials. So my add operation is to be targeted now. Representation I am able to develop, and let's go to the execution for the operation or logic for the operation. So one thing more important to be now remembered, that operation implementation also we will be taking care not to just think of simply copying the code or looking at the code and developing. I want all of you to learn methodology, how to develop the code given the logic or given the methodology clearly explained. So let's take two cases. Let's assume I have two polynomials. One is x raised to 5 plus 4x raised to 4 minus 3x square plus 5. Let's say there is another polynomial which reads out 2x raised to 5 plus 3x raised to 4 minus 5x cube minus 4x square minus 3x. I want to add both. How do we really add? We know in school what we have studied. We used to always write, let's say x raised to 5 plus 4x raised to 4. X cube term is missing, so we will write plus 0 here or empty here. Then minus 3x square. Then again plus 0 in terms of x, then plus 5. And just below, we will write the other term, 2x raised to 5 plus 3x raised to 4 minus 5x raised to cube. This may be minus 4x square minus 3x, and this could be 0 or empty left. So either you leave it empty or you write 0. It is one and the same thing. But now straight away, addition could be done. This becomes 3x raised to 5 plus 7x raised to 4 minus 5x raised to cube, and so and so. Effectively, in terms of my storage now, if you see, my first polynomial 1 is actually stored something like this: 5, 4, 0, minus 3, 0, 5. My polynomial 2 is stored actually nothing but 2, 3, minus 5, minus 4, minus 3, 0. So this is my second polynomial. And my polynomial 3 could be just by addition of the corresponding index elements. So I can, sorry, this was 1. Let me correct this. This was 1, 4, minus 3, and like. So this will become 3, 7, and so. So effectively, the result is nothing but array addition, and array addition logic you have already implemented in C also. So logic is simple, but this logic was applicable if degrees were equal. If degree were not equal, then what? If degrees are not equal, then what did we do? Again, how to make a logic? Thing is simple. Recall how did you do on paper in mathematics or during your schooling. Even if you don't know programming, but you have done this addition in the school level at some way. How did you do? For example, I have one polynomial as x raised to 5 plus 4x raised to 3x square minus 3x square plus 5. First polynomial is same. Let's say second polynomial is of order x raised to 7. So I may have x raised to 7 plus 3x raised to 6, maybe minus 2x raised to 5, and maybe 2x raised to 4 minus 4x cubed, maybe this empty, and maybe plus 3. Now, this is the way we used to write x raised to 7, x raised to 6, these terms to be written before x raised to 5 term, and accordingly, this addition can continue further. What effectively it needed? These two terms which are not there in polynomial 1, they will come as it is. And once these are there, rest is nothing but addition of these terms, but addition of corresponding terms. So this is a simple logic now, and I know this is what I have to do. So of course it means the solution is in two parts: uncommon terms or unique terms in one polynomial, and the remaining terms to be added one by one with each other. So if degree, in this case, what this case was, degree 2 was greater than degree 1. Hence, I copied the terms from polynomial 2. Vice versa also, similar will be there. If degree 1 is greater than degree 2, the similar terms will be copied. So knowing this, effectively, I should be able to write the code. So you should be able to write the program for the whole software or for this polynomial addition now using this logic. So I will say all of you to try and write a program for doing this work. Those who are looking at the video, so they should pause here and try to implement, and then once you are able to do it partially or fully, then you can come back to this video and again see what really you know. Those who are uncomfortable, those who are thinking that how to make totally at all not clear, for few initial classes, you can look at the solution partially, which I will be telling, but later you should attempt yourself to write. For example, in this case, I will say, today I will not make any modules and I will simply make all code in main. Later, we will be definitely making module based and make it a better code also. So for the time being, I will give a solution without modules, but later definitely we will improve to this, to modular programming also. Now, certain thumb rules. Number one, we should always aim to write initially a working program. Working program means your program should execute and give output for common inputs at least, giving correct output for common inputs, normal inputs or commonly used inputs. Once that works well, then your attempt should be to convert this program to a good quality program. So a good quality program will definitely mean that it should be a better program in terms of a readability. Of course, indentation will be always ensured. Along with the readability, it should also take care of giving correct output for all valid inputs at least. valid at least. So I must ensure that program to work well in those cases. And along with this, I should also have the modularity later added, or structured logic, and modular also slowly towards that. So then I will say it's a good quality program. So for that, again, while writing the logic during your coding, certain care to be taken care. We can always have, there is no harm if you want to make a logic by taking some extra simple variables or some extra simple statements. Simple variable mean if you declare, let's say, some extra variable int position, int k, even if you could write the code without these, there are simple variables. Simple mean they are say 1 or 2 or 3 variables, not arrays, not big arrays, 2D arrays, etc. Similarly, simple statements could mean if you have written some statement extra as I plus j, if you have written some variable position 2 equal to k minus j plus 5, fine, perfectly okay. Few extra statements, no harm. But avoid always extra arrays. Unnecessarily arrays should not be taken. Avoid extra, or I will say unnecessary, control statements. When I say unnecessary control statements, I mean no extra loops, no extra if, else, or switch case, etc. So these should not be unnecessarily taken. If they are needed for the logic, good enough, but simplicity or readability not to be compromised for adding or having these extra. This should never be the target. So I should always aim to have the corresponding arrays or unnecessary control statements to be avoided in these situations. Remembering this, let's continue and now make some logic towards this. So if you are again trying, give a pause, try to write the code of your own. Once you have done something, come back and see this. So for the time being, I am starting writing with main. First of all, I will declare certain variables. So maybe I will say degree 1, degree 2, and for final polynomial, I will have degree 3. Then I will have, let's say, array poly 1. I will declare poly 1 to be of size 50, poly 2 to be of size 50. Similarly, maybe poly 3 also of size 50. Don't declare it without size. That will be incorrect. Of course, some of you might be using some n, etc., and then dynamic, etc. Those we will understand later. We will initially target to write a simple codes using statements like this. So all variables taken. Now, first thing will be my program is effectively going to be certain components. What is the first step? Of course, read first polynomial. How to read, we will discuss, but that is first step. Similarly, my target will be read second polynomial. My third step will be add two polynomials. And final step will be display or print the result. Or display the addition polynomial, yeah, added polynomial. Now, these are the primary steps. So, and that will be the main over. I'm sure some of you might have done this. Let's target how to read first polynomial. How to read a polynomial. So polynomial reading means what? Polynomial reading means I need the degree, because without degree, I can't know how many coefficients will be there. So maybe I can initially give a message that enter the degree of first polynomial. I can give a message. it's always better to give a message. And then, of course, you will need a scanf, %d, ampersand, degree1. Today only I am writing all this code. From next class onwards, I will not write main, I will not write how to read inputs, how to display. Our focus from the next class onwards will be only onto the operation. So from next class onwards, I will not write the other parts, but today those who are uncomfortable, for them, I am just trying to put the main component for adding input and output also. So once done, I know now degree1 is known. Let's say degree1 was 5. Now what to do next? I have to read coefficients. Coefficients reading. How many coefficients to be read? This degree directly tells. If degree is 5, I am supposed to read a total 6 coefficients. Some of them could be 0, but a total 6 coefficients guaranteedly. X raised to 5 down to x raised to 0. So I need a loop. The loop is definitely going to execute 6 times and exactly 6 times. So in such situation, for loop is the best loop. No unnecessarily change, no unnecessary ambiguity. Everything is well defined. And if I write it as 0 to degree1, straight away loop works. Again, I can have here a scanf statement directly, but it will be always better to write a printf message telling the user which coefficient is being read. So maybe you could give a message, enter the coefficient of x raised to something to be printed here, so that user comes to know which coefficient is being printed here. So you can think of how to give that message. But ultimately, I need to read it at scanf level. Now, first coefficient to be read at which place? Into polynomial 1 at some index. That index is 0. Then next coefficient to be read at index 1, next at index 2. Hence, I can easily see that I can straight away write something like this. And similarly, the same process can be, this is first polynomial reading. Similarly, I can write second polynomial reading. Now, this becomes overall first and second polynomial reading. So, after that, my logic for the addition will come. If we make modular programming, all this could have been probably saved through modules by writing once, but doesn't matter. If you don't use, still it can work well. So, because my main focus is addition, not input, output, etc. So, how to do addition? So, I will say now I have to write the addition logic. Let's start working on this the way we discussed. Let's try to code that. What we have discussed. Addition will be possible through what process? By comparing and finding what is to be added. So we have already discussed 3 different situations. First situation was degree 1 to be equal to degree 2. So we will first of all check degree 1 equal to degree or not. But remember, whenever you have to check equality, you have to type double equal to. Single equal to is always used for assignment, so it's a common error. You should not do that. If degrees are equal, what I have to do? Effectively nothing but the array addition. Because all terms are common. So effectively common terms being added. And all terms are common. So common terms will be added and straight away ready. How to do this addition? How many terms are to be added? Degree 1 plus 1 or degree 2 plus 1. Total coefficients are those many. All are stored from index 0 to degree 1. And accordingly, effectively by writing a simple loop, I can add this. Of course, now loop also, because it is guaranteed to execute a degree 1 plus 1 time, a for loop can be the simplest and easiest choice. Else, other case, let's say degree 1 is greater than degree 2. Now what to do? How will you do this solution? So degree 1 greater. For example, first terminology has some x raised to 7, x raised to 6, x raised to 5, and then x raised to 4 onwards. Second polynomial has terms from x raised to 4 onwards. That means remaining terms or those terms which are uncommon, which are not present in second polynomial, they are to be copied as it is into polynomial 3. So what I need here? I need some logic to copy some terms. How many terms? Let me let me call my mobile. Yeah, sorry. So there was some mobile disturbance. So I will say what I have to do, copy some terms, and which terms? Which are uncommon, not common in both. From where? From polynomial 1. Copy from here to where? To polynomial 3. So from polynomial 1, some indexes to be used, polynomial 3, some indexes to be used, and these will be directly copied, no addition, etc. Then what else? Now, after copying uncommon terms, the common terms are to be added correspondingly. Now, correspondingly word I am stressing upon because this is a common mistake you will make otherwise. Remember, the terms in the degree 2, these terms will be present, or polynomial 2, their indexes will be guaranteedly 0 to degree 2 because they are lesser terms. But in polynomial 1, they will not be starting from 0. From 0 to some initial terms, they were uncommon, and only at some other index, the corresponding terms will be available. This much hint should be sufficient to you to understand what mistake you are likely to make. Like polynomial 1 is x raised to 7 minus x raised to 6 plus x raised to 5. Then x raised to 4 related coefficient is at index 3. But in polynomial 2, x raised to 4 related terminology is at index 0. So you have to be careful that those logics you take here. Then what is the third case? Third case is simple. It guarantees that degree 2 is greater than degree 1. And here also the logic will be similar. First of all, copy uncommon terms. From where to where? From poly 2 now towards poly 3. And then add common terms. In this case, of course, poly 1 as well as poly 2 correspondingly to be added to be going towards poly 3. So if I am able to make this logic, my program is almost ready. Just one more thing, that although the program is ready, ultimately I have to display the polynomial also. Displaying will mean all coefficients to be displayed. How many coefficients exist? As per the degree only. What is the degree of third polynomial? Has I stored somewhere? Till now, not. So it will be a good practice that if I store degree 3 also and generate this degree 3 based on the statements. So maybe here I can say degree 3 equal to degree 1. In other case, here I will say degree 3 is equal to degree 1 because degree 1 is greater. In third case, my degree will be nothing but equal to degree 2. And then once I know this, then I can display the third or added polynomial, display polynomial 3 using degree 3. So that will be the target which I will make. So I will stop here, and effectively now I'll ask all of you to try to write this complete code and make implementation as per your understanding. Next class, we will be talking of how this can be implemented in this way, whatever we wrote, and how it can be further improved to write it in a better way also. But something more to be taken care. Now, can you think any special situation where this code is not good? Any special condition, any special situation? So we normally call that for common cases, this works easily, but can there be some uncommon situation, any special condition, or I will say exceptional situation, which this code might not handle? So you have to always, once you have written a code for normal situations, think of any exceptional situation or not. Exceptional situation, I will again give a hint. What about my final polynomial? Will always that be of the degree which I have already decided? Can there be a situation where my final polynomial degree might itself change? If it changes, accordingly, my storage and operation should really take care of that. For the time being, even if you are not able to think of that, don't worry, that's not important, because 80-90% of the work is done. So code it yourself and try to run it for various inputs and check that. So try over different inputs. Always check your program for all different cases. So different inputs definitely mean you should check for equal degree. You should also check for degree 1 being greater than degree 2. You should also check for degree 2 to be greater than degree 1. And if you can think of some special or exceptional conditions, then those also to be targeted during implementation, if you can think of that. Otherwise, this much is also good enough. If you are able to code this whole program effectively, you have done 80% of the work. And next class, I will be talking of the better solution, good quality solution, if needed modular solution, and some more additions to this. And now I'll be stopping. All the best to all of you. Before the next lecture, you should be able to try it, run it. If you are not able to make next video, I will show the sample solutions also, and that will help you in a good way. Bye-bye. All the best.